What if we told you that the future of computing is far stranger and more powerful than you ever imagined?
Buckle up, because today we're diving into a topic that promises to reshape our world: quantum advantage.
Can quantum computers really outperform classical ones? Let's find out. Quantum advantage, or quantum supremacy, refers to the moment when a quantum computer can solve problems that classical computers practically cannot.
It's more than just a tech buzzword, it's a revolution in how we process information and tackle complex challenges.
But what milestones have we achieved on this journey?
One of the first major milestones was Google's announcement in 2019, claiming to have achieved quantum supremacy with their 53-qubit processor, Sycamore. They performed a calculation in 200 seconds that would take the world's fastest supercomputer about 10,000 years.
This was a landmark moment that sent shockwaves through the tech community. But achieving quantum advantage isn't just about one company's success.
Other players, like IBM and Rigetti, have also made significant breakthroughs, pushing the boundaries of quantum computation.
So, how do we benchmark these achievements? What tests are used to measure quantum performance? Benchmark tests for quantum computers often involve comparing their performance against classical algorithms.
These tests evaluate metrics like fidelity, coherence time, and gate error rates.
A surprising fact?
Even minor improvements in these areas can lead to exponential increases in computational power.
Now, let's pause for a moment. Have you ever wondered how quantum computing could impact your daily life?
From drug discovery to financial modeling, this technology promises to revolutionize various sectors.
Stick around as we dive into real-world applications next.
In healthcare, quantum computers are already being explored for their potential to simulate molecular interactions, leading to faster drug discovery processes.
Imagine developing new medicines in a fraction of the time it currently takes. That's the power of quantum.
Furthermore, in finance, quantum algorithms can analyze vast datasets to optimize portfolios and assess risks in real time.
Financial institutions are investing heavily in this technology to stay ahead of the curve. If you find this fascinating, make sure to like and subscribe for more content on quantum breakthroughs. Let's not forget logistics and supply chain management, where quantum computing can streamline operations by predicting demand and optimizing routes. This could save companies millions and reduce carbon footprints significantly. The implications are staggering. But despite all the excitement, challenges remain. Errors in quantum computations can lead to catastrophic failures, a phenomenon known as decoherence. Researchers are actively working to overcome these hurdles. Are we truly ready for a quantum future? As we look forward, the potential of quantum computing is thrilling.
From artificial intelligence to cryptography, the applications are endless.
Are you as excited as we are about the future of technology? Let us know in the comments below.
In conclusion, quantum advantage is not a distant dream anymore.
With milestones achieved and real-world applications emerging, we're on the brink of a technological revolution. Don't forget to subscribe and hit the bell icon for notifications on our next video, where we will explore the implications of quantum cryptography.